Now, next, we're going to look at compound interest. And as I mentioned in the previous video, simple interest is interest earned on only what you initially deposit. So in particular, with simple interest, you don't earn interest on interest. But compounding interest is interest that's earned on the initial deposit plus any interest you've accumulated in time periods before that. So for example, with simple interest, if you earn interest every year, after 3 years, you've earned interest after the first year, you've earned interest after the second year, but you're not earning money on that interest. With compounding interest, after the first year, so in the second year, you're earning interest on the interest you earned in the first year. So definition, compound interest is interest earned on both the original principal and any accumulated interest. And we're going to see that, we're going to see examples where we have a compounding period, meaning, it starts accumulating interest. You could say if it's an annual interest rate compounded annually, then after each year, you start earning money on previous interest. But it could be, it compounds each quarter. So after every 3 months, you earn money on interest that you earned in those first 3 months. Compounded monthly, it's you earn interest every month, and you earn interest on that interest that you earned each month, and so on. But the compounding period is the interval on which compounding is done. So let's look at two examples. Yeah, let's look at two examples and then use them to derive a formula. You deposit $1,000. This, I believe, does parallel the first simple interest example. Yeah. You deposit $1,000 at and maybe I should phrase it the same, an account that pays interest at an annual interest rate of 10%. So 10% annually. And here we're going to mention compounded, that interest is compounded annually. So this means, so in the first example of simple interest, year 1 you earned 100, year 2 you earned 100, year 3 you earned 100 in interest because you earned only on the original 1,000. But here you earn interest in the first year, and then in the second year you earn on that. So this question will be, how much is in the account after 3 years? Well, let's do this year by year. After 1 year. So after 1 year, well, how much interest is earned? It's compounded annually, so during year 1, we're not earning on any previous interest. So we have here, it was P, then R, then T. The first time I wrote that, I wrote backwards. So we have the initial amount times the interest rate, the annual interest rate here, and then it's, we're just looking at what happens in 1 year. So we have this much interest earned. Maybe I shouldn't say after 1 year. I'm going to change that. During, how should I say it? I want to say interest earned during year 1. That's a lot of words. So I'll just say that's technically at the end. Okay, sorry, leave it at after 1 year. No, it may not be clear why I'm debating this phrasing. I'll say interest earned during year 1. Okay, sorry about that. Interest earned during year 1. Well, we have $1,000 at the beginning of year 1, and we have 10% interest rate, so 1,000 times 0.1. We earn $1,000. And how much is in the account after 1 year? So interest earned during year 1 is $100. in the account after year 1 is what? Well, it's the initial 1,000 plus the next 100, so that's 1,100. Now we need this 1,100 in order to figure out how much interest is earned during year 2. I guess I'm going to go to a new page. We need to figure out the interest earned during year 2. We need to get to a new page. Taking its sweet time. So interest earned during year 2. Well, with simple interest, we knew that from the year 1 computation because it was just 100 per year, because we earned only on the $1,000. But here, we're earning 10% interest on the amount at the beginning of year 2, which is $1,100. So in particular, we're earning interest on the original principal, $1,000 plus the $100 of interest earned. We're again earning 10% of that. 10% of this is what? $110. So how much is in the account after year 2? Well, it's the amount at the beginning plus the $110. What was that? $1,210 after year 2. So with simple interest after year 2, it was just $1,200. But here, notice we earned an extra $10 because we earned interest on interest. This question asks about year 3. That's the second time I misspelled earned. I forgot the E before D. Interest earned during year 3. Well, how can we find the interest earned during year 3? Well, we take the initial amount at the beginning of year 3, $1,210. It earns 10%, and that's $121. So it earns $121 in interest in year 3. So the amount in the account after 3 years, in account after year 3, which is what this question wanted, is the initial amount, $1,210 at year 3 plus $121, which is what? 1331 should be 1331. And we did that, through brute force by going through each of the compounding periods. Here, compounding period, it said compounding annually. That means that we start earning interest on interest. Well, we earn interest on interest for each year. Let's look at, before looking at another example, we've seen some of these numbers before. And we've seen 1331 before in this class. We've seen that 121 before. We've seen some of those numbers show up before. That is not a coincidence. That example was set up to give numbers like that. So you can imagine for the next year, what would happen. It would be probably 1464 and 10 cents. Would it be? I believe it should be. You can check that. But let's go to another example before, and let's use this next example to help derive a formula. You deposit $1,000 again at 10%, but instead of compounding annually, so it will say at a 10% annual rate, but here we're going to change the compounding periods. Compounding quarterly. How much? Quarterly meaning a quarter of a year, so 3 months. How much is in the account after 1 year? Well, there are 4 quarters in a year, so let's figure out how much is in after 1 quarter, after 2 quarters, after 3 quarters, and so on. But to do that, if we're gonna, I'm gonna leave a gap in space. I'm gonna write something there in a moment. And down here, I'll just say after 1 quarter, how much is in the account after 1 quarter. But I am going to write something in there because we're going to figure this out by figuring out what happens in each quarter. But our interest rate is an annual rate. So what we're going to have to do is make that a quarterly rate. And how are we going to do that? Well, our annual rate is in, the units are years. So we need to get that in quarters. So we'll divide it by 4 because there are 4 quarters in a year. So you know, the years. Well, years is technically in the denominator. It's percent per year. So we would do times years divided by quarters. So times 1 year over 4 quarters. So I'm going to write that up here. Remark. It's compounded 4 times per year and 10% per year. So the interest, maybe I'll say, so the quarterly interest rate is 10% divided by 4, which is 2.5%. We're going to find this going through quarters. Our rate is going to be, our quarterly rate is going to be 2.5%. And we're going to figure out how much interest and then the total amount at the end of the quarter. So interest after 1 quarter, what are our numbers here? So I'll say interest earned is $1,000 times our 2.5%, so 0.025. And what is that? $25. So after 1 quarter, this account earns $25. So the account has 1,000 plus $25, $1,025 after 1 quarter. And we're going to do this for the next quarter. After 2 quarters, interest earned is, what is it? Well, we start at 10.25 and we earn 2.5%, which is what? About $25.63. So about $25.63. That didn't stay on the page. About $25.63. So how much is in the account? After 2 quarters, the initial 10.25 plus the 25 and 63, which is 10.50 and 63. Oh wait, we don't want after 2 quarters as a final answer. Maybe I'll box the ending amount each time. And now we need to do this for the next 2 quarters. So after 3 quarters, how much interest? Let's say interest. We start with 10.50 and 63 cents. We earn 2.5%, so 0.025. And this is approximately equal to, where I wrote it somewhere, 26 and 97 cents. Oh, not 97, 26 and 27, excuse me. Sorry, $26.27. So the account has 10.50 and 63 plus 26 and 27, which equals what? 10.76 and 90. That's after 3 quarters. This question asks how much is in after 1 year. Well, that's the same as how much is in after 4 quarters. So how much is in the account after 4 quarters? Well, the interest is earned on the 1076 and 90 cents at 2.5%. And this is 26 and 92. That's where I got the 9 from. I'm not, I hope none of you thought I was doing some of these in my head. I have these numbers written right there in front of me. So where were we? After 4 quarters, the interest earned is that. So we need the amount in the account. The account has how much? 1076 and 90 plus 26 and 92, which is $1,103.82. That's pretty close to my birthday. That's 9 years off of my birthday, which may be why I chose that example. Maybe it's just in the textbook. So we could go through each compounding period to help figure out by going through each compounding period, but we could generalize this to a formula, because you'll notice, in all 4 of those computations, the initial amount showed up, the interest rate showed up. We added it together similarly to the simple interest formula, but the compounding periods do make it a little more complicated. So do I want to give you the formula then derive it, or do I want to derive it and then give it to you? Well, first, let's go to a new page. I hit the button. Okay, sure. First, our interest rate, notice in those last 2 examples, we handled the interest rate differently. So I'm just going to write this as a remark. Remark. We're going to call it the periodic rate. So it's a remark and a definition. Periodic rate, we're going to call it lowercase I, and it's equal to R over M. And I'm going to define these variables. R is the annual interest rate. M is the number of compounding periods per year. Periodic rate, I, is the interest rate per compounding period. So there will be times where we talk about the interest rate per compounding period, just I. And we could find that by taking the annual interest rate and dividing it by the compounding period per year. Years cancel out and you're left with interest per compounding period. So I'll say periodic rate. Sorry about that. Periodic rate is I, and it's defined by that. And I'll just say gives. Well, I'll say I gives, because it's okay to start this sentence with a lowercase. Actually, it's technically not, because you're not supposed to start a sentence with a math symbol. I gives the interest rate per compounding period. So let's try to find a formula for compound interest. I hope this will all fit on one page. So let's generalize the previous example. So derivation of a future formula called compound interest formula. Derivation. How are we going to do it? Well, we're going to generalize the previous example. In the previous example, this lowercase I was our, 10% divided by the number of compounding periods. So in the previous example, I was our 2.5%. So how much was in the account after 1 quarter? What were the letters and things we used? How much was in the account after 1 quarter? Well, what was in the account? 1,000 plus 25. How did we get that? Well, it was 1,000 plus 1,000 times 0.025. So P is going to be our principal. P is our principal. So it was P plus the 25. Where did that come from? P times the interest rate I. So I'll say in parentheses using previous example. So in the first, or after the first quarter, it had P times P plus I, 1,000 times 1,000, or sorry, 1,000 plus 1,000 times the periodic interest rate, the interest rate per compound rate. And this, you can simplify that, P times 1 plus I. Well, what was in after 2 quarters? After 1 quarter, we had P plus, or P times P plus I. So after 2 quarters, we had the initial amount, which was P times 1 plus I. The initial amount, remember, was the ending amount from the previous quarter. But we also earn interest on that. So in that example, it was what, 1025 plus 1025 times 0.025. So we needed to take the initial amount, and we needed to add the initial amount times another interest rate. So it was the initial amount, P times 1 plus I, plus that initial amount times another I. That's a pretty complicated formula, but notice it does simplify nicely because, we have those two quantities here, which are underlined. Each underlined quantity has a P times 1 plus I. So we can factor out a P times 1 plus I from both pieces. You take a P and a 1 plus I away from that first piece, you're left with a 1, and you're left with nothing, but with multiplication, nothing is 1. You can relate what I just said, nothing is 1, to our group's discussion. You take a P and a 1 plus I from that second term, you're left with an I, and there's a plus sign in the middle. So we factored that out, and notice what's in the curved parentheses is the same as what's in the squared parentheses. So we can just write this as P times 1 plus I squared. Well, let's see what happens after 3 quarters, and then we will generalize this. After 3 quarters, well, we still have, what was it, 10 in that example is 10.50 and 63 cents plus the interest, which was 10.50 and 63 times periodic interest rate I. So here, after 3 quarters, we have our initial amount, P times 1 plus I squared, plus the interest earned, which is interest earned on that initial amount. And again, we have 2 pieces. The first piece is the initial amount in the account. The second piece is the interest earned. But we have those 2 pieces. We can factor out. Those 2 pieces share in common a P, and they also share 2 1 plus I's. We can factor that out. Factor it out from the first thing, you're left with nothing, so 1. Factor it out from the second thing, you're left with a positive I. And again, we have another 1 plus I. So P times 1 plus I. There are 3 copies of 1 plus I, so we can write that as Q. And after 4 quarters, you could check what you get, but you would get a 4 instead of a 3 in your final formula. And that does hold in general. And I'm not going to fit this on this page, so I need the page. Am I going to give both formulas? So there's one formula with the I rate, and then there's one with the R over M rate. I guess I'll give both. Yeah, I guess so. Compound interest formula. I'm going to call this 1. an initial principal P in an account that pays interest at periodic rate I. And remember, the periodic rate is the rate per compounding period. That's why it's called periodic rate. I'm going to put in parentheses rate per compounding period. And just to really hammer that down, it's the rate per compounding period. An initial principal P in an account that pays interest at periodic rate I grows after n compounding periods to A, which equals P times 1 plus I to the n. So notice here, there is in this formula a good deal of work built in because I and n need to share the same units. We need a rate per compounding period to do the same as our number of compounding periods. But we have this written in general, but I will also give the more specific formula, and I'll call it using annual interest rates. I'll just say using annual interest rate in 1 gives the following formula. And I'll call it compound interest formula 2. And we're going to need the same variables, but a couple different ones. And initial principal, they're capitalized for some reason here, P in an account that pays interest at an annual rate R compounded M times per year grows after. So in in Formula 1, we've just spoken general compounding periods, but here everything is in years. So we have annual rate compounded how many times per year, compounded M, lowercase m, times per year, grows after, and our time unit in the previous one was compounding periods. Here, our time unit will be years, so grows after t years to what? What is it? A equals P times 1 plus the rate over the compounding periods to the M times T. And M times T, notice it's what? T is years, M is compounding times per year. So M times T is the number of compounding periods. So these two formulas are the same if we just the second one is just changing everything into annual numbers. The first one is written in general. But let's use let's see an example. Actually, 2 examples. Are these? Yeah, okay. Let's do 2 examples where we use these formulas. And in these, well, in these, I guess I'm going to use the second formula in both of them. No, for the first one, I use the second formula. For the first one, I'll use the second formula. For the second one, I'll use the first one, I guess. Example. Suppose I'm going to do the first one with the first example and the second one with the second example. Or the first example with the first formula, the second one with the second formula, because actually the last one I want to be something. Suppose you have $5,000 invested at 0.41% interest per year. Determine how much is in the account after 7 months with monthly compounding. So I'm going to use the first formula, the one where we use a the I rate, the interest per compounding period. So here we notice our compounding period is monthly. So here I would be our interest rate. So it's given as 0.41. As a decimal, that's 0.0041. We have it's a monthly compounding, so there are 12 compounding periods per year. And I don't have a calculator on me, so I have to use my computer's calculator. 0.0141 divided into 12. And this is approximately 0.00, well, that's exactly, let's just use the exact one, 1175. So right here is our interest rate per compounding period. It's an interest rate per month in this case, because those are our compounding. That's our compounding period. Now, what was the letter N? Yeah. So N in that first formula is the number of compounding periods. Well, monthly compounding, we're looking after 7 months. So that's 7 compounding periods. So the amount in the account is P, 5,000, times 1 plus I, raised to the number of compounding periods, 7. And this is approximately equal to 50, 41, and 27 cents. And an answer pretty close to 5,000 should be expected because it was a very low interest rate. Even though it is earning every month, it's still a pretty low interest rate. So we should expect that answer to be close to 5,000. But let's look at another example. I'm debating if I'm going to be able to fit this all on one page. I think I will be able to. Example. Suppose you have $1,000 invested at 10% interest per year. Determine the amount in the account. Now, I do realize that rhymes. Part of the reason I say it so much. After 10 years with W slash nomenclature over there. 4 parts. A. I'm going to write them like this. A, B, C, D. A. Annual compounding. B. Quarterly compounding. C. Monthly compounding. D. Daily compounding. Well, let's start with annual compounding. And here I'm going to use the second formula because everything is in years. The last one we had months thrown all over the place, but here, our time is in years. With daily compounding, if you have to deal with that, you have 3,650, whatever, 3,650 compounding periods. But here, we will actually see where that shows up. Annual compounding, well, we use the second formula. I'll do a colon. Start with $1,000. 1 plus the annual interest rate. Annual interest rate is 10%, so 0.1 divided by the number of compounding periods. Well, with annual compounding, divided by the number of compounding periods per year. That is how I phrased it over there, right? Yeah. Number of compounding periods per year with annual compounding is just 1. Maybe I'll say 0.10. And we raise this to what? To it's compounded the number of times per year, the number of compounding, the number of times it compounds per year times the number of years. Everything here is in years. So we would have 1 times 10. And this is approximately equal to 25.93 and 74 cents. Next, quarterly compounding. So here, quarterly compounding, we're going to have 4 compounding periods per year. So in particular, M equals 4. But we still start at 1,000 times 1 plus the annual interest rate divided into 4 this time. And then we raise it to that 4, the number of compounding periods per year, times the number of years. Notice that exponent. Well, let's write the answer now. Notice that. And this is approximately equal to 26.85 and 6 cents. So notice with quarterly compounding, it compounds every quarter. It compounds 4 times per year. And we're looking at 10 years. So there are going to be 40 compounding periods. And notice that 40 does show up in our exponent. And with something like that, you can actually see how the two formulas are the same. Because the one exponent, takes into account the exponent n in formula 1, builds into it that we have this, this number of compounding periods per year times the number of years. It builds into it the fact that gives the number of compounding periods. But here with the second formula, we see where that comes from. So here our exponent is 40. How about monthly compounding? Well, the number of compounding periods per year is 12 here. M is 12 here. So we have 1 plus the annual interest rate, 10 divided by the number of compounding periods, raised to the 12 times 10. There are 120 compounding periods in 10 years with monthly compounding. And this is $2,707.04. And finally, with daily compounding, it compounds every day. We'd still have that original 1,000 times 1 plus annual interest rate divided by the number of compounding periods per year. Don't worry about leap years. We'll just say 365. Daily compounding compounds every day. So there are 365 compounding periods in 1 year in this case. M equals 365. And our exponent would be the number of compounding periods per year times the number of years. And this is approximately equal to 27.17 and 91 cents. And notice these answers do increase. And we should expect that because the number of compounding periods becomes a smaller time period as we go. So it's going to earn interest a little faster as it goes on. But this last example illustrates something. So notice in these 4 it does increase. So what if we change daily compounding? It compounds every 12 hours, compounds every 4 hours, compounds every minute, compounds every second. How much would this grow? Well, there is a limit to how much that will grow. And any of you who have seen calculus before, the use of limit here is the same as the use of limit there. But it's not gonna, if you break your compounding periods into as small of time periods as you can imagine, this isn't going to keep getting infinitely large, the amount in the account. There will be something that stops it. And we'll actually see that it's very close to daily compounding, but that will be our next video.